The question says that at what distance would the lens be held from the card sheet in exercise 9.22 in order to view the squares distinctly with the maximum possible magnifying power. Now here it is asking what is the distance of the object from the previous question so that we can view the image properly with the maximum magnifying power. Now this question is taking the data from the previous question, and the data are focal length of the convex lens was 10 centimeter, and now here we have to find out the magnification, the magnifying power or the angular magnification for the image to be formed such that the eyes could see distinctly. So for the squares to be visible distinctly, the image should form at the least distance of distinct vision, that is 25 centimeter away from the eye. Now so that we can deduce from this is that v should be equal to minus of 25 centimeter. That is, the final image should be at least 25 centimeter away from the eyes. Now so we have got the value of v, we have the value of f. Now we have to find out the value of u such that this case is met. Now here we have to find out what is the magnification in this case as well. Now here this magnification, the value of m is going to be equal to v by u, and whereas this is small m, the magnification is represented by small m, and the magnifying power is represented by capital M. So we have to find out the magnification as well. So we have to find out the value of u so that we can use the formula v by u. Now we also need to comment that is the magnification equal to the magnifying power. Now we have to comment that is this magnification equals to the magnifying power. So we have the formula ready that is to be used, that is the lens equation. So 1 by v equals to 1 by v minus 1 by u equals to 1 by f. Now here 1 by v, we can put the value of v as 25 centimeter. With sign convention, it would be equal to minus of 25 centimeter. We have to find out the value of u, and the value of f is given, that is 10 centimeter. Now the value of u from this calculation is minus of 7.14 centimeter. Now here we know that angular magnification is given by d divided by u naught, or the distance of object from the object. So this is the angular magnification. It comes out to be a value of 3.5, and this is the magnification. So this can be given by v divided by u, and this is same as the angular magnification. Now here we have found out the value of linear magnification in this case, and we saw that is the magnification equal to the magnifying power in this case. Then we saw that the answer of this question is yes. Now how did this happen? How did the magnification become equal to the angular magnification? So we know that now angular magnification is given as the visual angle formed by the final image divided by the visual angle formed by the object at d. Now the formula for angular magnification is capital D upon u naught, where u naught is the object distance from the objective or the lens. Now linear magnification was given. Now magnification is given as v by u. Now here we saw that in this case, when the final image is at d, then we can write v as 25 and u is the object distance. So we can write it u naught. So we can see here that m is equals to m. Capital M is equals to small m, or the angular magnification is equals to the linear magnification. So we can say that whenever the final image is forming at d, then we can get the angular magnification is equals to the linear magnification. Thank you.